Hey, boys and girls, welcome back, everyone. One thing I want to talk about are the tools that we use in science class. As you know, science is a way of knowing, and so we want to make sense of the world around us. In order to do that, we need specific pieces of tools and equipment to understand the world. And so we're going to introduce a couple of them to you. Many of them I'm sure you've heard about before, maybe heard in the past or whatnot, maybe test tubes or beakers. We're going to identify them, how they're used, and so forth. So, the first thing you have to acknowledge is that in science, when we communicate certain measurements, it would be difficult if we're talking about inches versus meters, or looking at something like pounds versus grams. And so, we have a system that we use to communicate that you heard of called the metric system. There's a mnemonic at the very top of the page there you can see that goes King Henry died unusually drinking chocolate milk. And basically, it's a simple way to memorize the biggest units, like a kilogram, all the way down to the smallest units that are familiar, like milligrams, things like that. As you see in the middle column, we have our base units like meters, liters, and grams, which meters measure length, liters measures volume, and grams measures mass. And so these parts we're going to use frequently. We won't really use hectograms and decagrams or decigrams that often, grams, liters, meters, but we're going to use them from time to time. You'll probably hear of kilograms frequently, or milliliters, you'll hear about them, or centimeters. So it's good to understand where on this chart those numbers in units come from. Now remember, the nice thing about using the metric system is one, there are no fractions. Two, they're base tens. Everything's base 10. And three, when you have to convert, all you have to do is slide the decimal over. To go to a bigger value, you slide the decimal to the left. To go from something like a gram to the kilogram, you would slide it 3 times. To go to a smaller value, like a gram to a milligram, you would slide the decimal to the right and add the zeros that follow that. So, as you know, the metric system is there for you, and there are certain easier ways to convert in between those units. Now, one piece of tool, one piece of equipment you probably have seen before. This looks like a ruler because it's small on the screen, but it's actually a meter stick. A meter stick makes measurements. It's 1 meter long. It's actually longer than a yardstick. It is. A yardstick is basically 0.94 of a meter stick, and here it makes measurements in centimeters. Every line there, every number on this meter stick is making measurements in centimeters. Every tiny line, tiny segment is measured in millimeters. Okay? So it's used to measure length. That's the main purpose of using a meter stick. This tool here you just saw this past week. This tool is what we call the triple beam balance, and its main purpose is to find the mass of an object. Mass is the amount of matter that makes up a substance, makes up stuff. And so we use gram to find what mass is. This is kind of what we could say how much something weighs here on Earth. Now, don't forget, weight is a component of gravity, but needless to say, we're using to find the mass, how much something weighs right here on Earth. The next tool that's commonly used in science class all the time is called the graduated cylinder. Graduated cylinder. And this tool is used to find the volume of liquids. Now, typically, we use something that's called milliliters, or ml. And so this helps us measure liquids to understand how much of a liquid we have. Now, if we use a glass graduated cylinder versus a plastic, the liquid inside can behave a little differently. A glass one will typically form some kind of curve in the center where the liquid dips down. That's kind of due to the bonding of the surface, the liquid to the surface. That little dip down is what we call a meniscus. Nothing you have to worry about, but just realize when we measure volume, we measure the middle parts of the liquid as it falls on that line. The next tool that we have is called an Erlenmeyer flask. An Erlenmeyer flask is quite commonly used for heating and holding liquids. Now, one thing to look for in class when you see a tool like this is you'll notice they have these stamps on the side, or what we call Pyrex symbols. Those Pyrex symbols mean that they are heat proof. Should we ever heat them up? You never want to use any glassware that's missing those stamps or those labels there. That means they've not been heat proofed or heat tested. And as a result, they could break, they can shatter, they can explode if they're heated to too high of a temperature. Now, as you can see on the side of this this flask, it measures in milliliters as well, from here 200 up to 500. Although this can show us how much liquid is in the flask, it's not the best for doing that. It's best for holding and heating up liquids. We would refer to something like a graduated cylinder to get a very accurate measurement. This one's the most common one students confuse all the time. This one is called a beaker, and we also use this one for heating up, holding liquids, or mixing liquids. It also makes its measurements in milliliters and so forth, and you can notice the numbers that can drop down from the top or up from the bottom. We can measure how much of a liquid we pour off from the container or how much we add to the container by using those numbers there. Notice you can see it also has that Pyrex symbol, which means it's also been heat proof. The next tool or piece of equipment we use frequently is called the test tube. And a test tube is used in many different applications. You can put it in a lab where there's a sample of blood, and we can put it in a tube that spins around really fast and draws the heavier liquid, the heavier components of blood to the very bottom, leaving the remaining lighter liquid of blood to the very top like plasma. Now, obviously in class, we're not going to be centrifuging any kind of samples of blood. But basically in class, we might dispense or pour some liquid into a test tube, draw some out and mix it with others. And its main job is simply just to hold liquids. You'll notice that most of our test tubes, if not all of them, don't even have those lines on the side to measure milliliters. That's because we measure the liquid before we put it into the test tube. Next, we have these small little items called pipettes. They look like an eyedropper. They're very similar, but the difference on these ones is that you'll notice they have ridges on the plastic edge here, the neck. Those are used to measure liquids accurately. So when we want to dispense 1 milliliter, a half milliliter, or 2 milliliters exactly, this is one of the tools we'll use to achieve that. Once again, its measurements are done using milliliters. Next, this is one of the older versions of what we call a test tube rack. So those fancy test tubes you saw earlier, we'll place them in here. We'll label them. We can use either a wax pen or a piece of tape to mark down test tubes A, B, C, D, or numbers 1 through 5, however you want to organize yourself while you're working in a lab. So they hold test tubes, which is their main function. This object kind of looks weird. It's a little square. It's known as a hot plate, and the hot plate is used for heating up materials. One main thing to recognize is the hot plate makes its measurements using degrees Celsius. So in class, once again, when we talk about using the metric system, 0 degrees Celsius is where typically liquids like water will freeze. 100 degrees Celsius is where things like water will boil. That's much different compared to 32, where water freezes, and 212, where it boils, using the English-based version. It's much easier to remember 0 and 100. And so once again, it makes its measurements using degrees Celsius, and they can get extremely hot, over 200, sometimes 300 degrees Celsius. This weird octagon-like shape object is known as an alcohol lamp. And we will use this from time to time when we have to heat up a substance under a ring lamp. We'll hold it down, or ring stand, and it heats up liquids or powders if we need to in labs. This object we have here is what we call a watch glass. And a watch glass is great for making small observations, very small experiments. You can see, how does a liquid affect a powder when you mix them together? Does it fizz? Does it give off a gas? Does it create a weird smell? Any of those things can happen when you mix them together. And that's the nice thing about using a translucent piece of glass, So you can see very closely before I mix a lot of it together, how does this small amount actually impact? Maybe nothing will happen. That's good to know. But maybe something does happen and you can isolate that and figure out what's going on. So those are the tools of science. Hopefully they made sense. As always, if you have questions, review back, take a look at them, or ask. Good luck. I'll see you later.